Yes, class. Am I audible to all of you?
Yes, ma'am.
Alia, Siddhika, Harsha. Okay. Yes, class. So in the last class, we had completed till kinetic energy we have completed. So now we are left with potential energy from your work energy and power. So let us complete potential energy also. So your energy will also be completed. See, potential energy. After first listen here, then look at the screen, then you will be able to understand. Potential energy basically means whenever two objects are present and they are able to exert force on each other, you get potential energy in a system wherever you have interaction. And what is meant by interactions? Interactions mean if you are able to exert force on an object. For example, two masses are kept and one mass is able to exert force on this mass, and this mass is able to exert force on this mass. How will they be able to exert force on each other? They are masses. You have not studied gravitation. After this, the next lesson, that is last lesson of your first book, there we study gravitation. There you have gravitational potential energy. So in that case, gravitational force will be exerted, because of which the system will be having gravitational potential energy. So, or let's take an example. If I take two charges and I'm keeping the charges like this, so one charge will exert force for, if let's say both the charges are positive, so both the charges will repel each other. So one force will be exerted here, one force will be exerted here. If they are able to interact means able to exert force force on each other, exert forces of repulsion, attraction on each other. That is how potential is generated. So whenever you have potential energy in your class 9th, also you people have concept of kinetic energy. There we study in 9th class that kinetic energy comes in the system whenever there is motion, right? Only when motion occurs in the system, we are able to observe kinetic energy. This is what we have seen studied in class 11th also. One more thing additional to your class 9th, what we have studied in class 11th is that whatever is the work done, that is equal to the change in kinetic energy. That's it. But in potential energy, if you people remember the definition of potential energy, which you all have studied in your lower classes, in your 9th class, 10th class, is that whenever the energy possessed due to change in configuration, change in shape, change in height, that's not the only definition of potential energy. Even if two masses are kept, they are not even moving, and still they are able to apply force on each other, exert force on each other. That is, they are having conservative interaction. This is what is meant by a conservative interaction. Conservative interaction means two bodies are able to exert force on each other. There is work done produced, potential is there. That's how potential energy comes into the system. Fine, even if two planets are present, even if they are moving, they'll have kinetic energy because their velocities are there, their mass will be present. But apart from it, they'll be having potential energy. Why they'll have potential energy? Because they'll be exerting force on each other. First and foremost definition is this. And because of this definition, you have the definition which I have written on the screen, that it's the energy possessed due to change in the position, size, or configuration in a field. Fine. This is how we get. It's not only in your lower classes, you have also studied this, that potential energy is mgh. Kinetic energy is half mv square. That's fine. Here also kinetic energy was half mv square. You've studied that potential energy is mgh. mgh is not potential energy. That is a very special case of potential energy, and that will come to you in class 11 as a proving question, that prove that potential energy of this system is mgh. That is not the formula of potential energy. You cannot remember it as the complete formula. Formula of potential energy is simply work done, because it's energy, so it is the work done. But how would you identify that potential energy is there in a system? Because the way I'm giving you an example, two masses are kept. Suppose these are the two blocks, they are kept like this. There is no change in position. Their sizes are also fixed. So in such cases, we'll say there is no potential energy. But no, you cannot conclude the fact that there is no potential energy, right? Why? Because they are able to exert gravitational force on each other. Gravitational force, electric force. Gravitational force you will do in class 11th. Electric potential energy you will do in class 12th. But no worries, you will be able to manage. When we do this case, no, suppose this is Earth of mass m. This is a small object which I have brought above. So this will be exerting gravitational force on it, and this will be exerting gravitational force on it. And hence there will be a potential energy in your system. Or one more example, this is from your class 12th, that if one charge is present, another charge is present. This will be exerting force on this will be exerting force on this, electric forces. So since electric forces are being exerted, they are interacting. This means they are interacting. If somehow because of the presence of medium or because of the presence of distance or any other factor, the forces are not being exerted, so we say they are not interacting. That is what is meant by interaction here in physics. So potential energy always comes in your system because of interaction, conservative interactions. Now, we have studied the concept of conservative forces and non-conservative forces. So always remember, whatever is the work done, that gets stored in the form of potential energy, and this applies in a conservative system. But if there are no presence of conservative forces, then there is no presence of a single conservative force, then what will you do? For non-conservative forces, it will vanish as heat. Suppose I am rubbing both my hands. Whatever is the work done, there isn't any force exerted. So now what will happen? There was a because this is not a this is a non-conservative system. So what will happen? I will feel hotter in my palms. I will feel hotter. Why? Because friction force has been generated, which is a dissipative force. So always remember, for non-conservative forces, it will dissipate as heat. All right, this will dissipate it. Yes, one more thing. When we talk about potential energy, you have to know what is meant by internal force. Suppose system, word system means what? System means the area under consideration. For example, this universe is so huge, you all know. So an example I'm taking, let me consider sun. Sun is there. This is exerting force on Earth. Earth has the moon. Earth has its moon. That's it. This is the orbit. Now, are these three just present in our system, in the entire universe? No. There are other planets which we already know. There are so many galaxies. The entire universe is not just made up of Earth, the moon, and the sun. But right now, I am just considering sun, Earth, and moon. This part, sun, Earth, and moon, this is my system right now. The part under consideration. All right, so this is my system. You can form a system. This is a very huge system which I have taken. I can take a very small system. For example, if I take a glass of water, which is kept on a table. So this table and this glass, this is my system now. Anything outside this becomes surrounding. This you will study in your thermodynamics. System and surrounding, these terms will come again. So right now only understand what is meant by system, what is meant by surrounding. All the forces that will act in you within the system. For example, the sun is exerting a force on Earth. So this is the internal force. That is what is meant by internal force. Earth is exerting force on moon. Earth is exerting force on sun. These are all the internal systems. Any other force right now will not be considered as internal force. That will be the external force. Right now, let's take a very small example. A glass kept on a table. That's it. Not the sun, not the moon, nothing. All these are now a part of your systems. So glass will be, suppose, let's say this is having normal reaction and this is producing Mg. These are right now the internal forces. Right now, internal forces. Suppose this glass and this table both are in Earth. Fine. And my system is just, let's say, sun. So these will be now the external forces because they are outside my system. So this is what is meant by internal forces. Internal, why? Because these terms are commonly used: internal forces, external forces, these types of terms. All right, so internal forces are basically forces within the system. So you just have to know the concept of the term system and surround. System means part of universe under consideration. And what is surrounding? Universe minus the system which is under consideration. The rest of it which is left, that becomes your surrounding. Fine. One more thing, when I say isolated system, you have heard or you will come across terms like isolated system. In an isolated system, the police acting a force like this. Isolated system basically means that the net force in your system is zero. So these terms will come. So just have a habit of using them. The way we have kinetic energy theorem, we have potential energy theorem also. So same, what was kinetic energy theorem? Work energy theorem, which we did, work kinetic energy theorem. It meant that whatever was the work done is the change in kinetic energy. Same here you have in your potential energy also, work potential theorem. Work potential theorem basically means that suppose this is a point having potential energy A. This is a point, final point, it is having potential energy B. So what is the change in potential? Final potential minus initial potential. That is UB minus UA. So this change in potential will be equal to the work done by the external force to move AB. That's it. If I want to find out the work done by internal force, do you understand why did we study the term internal force right now? So as to differentiate what is internal force, what is meant by external force. Because you do not have a list where you have certain names. Centripetal force is external force, normal reaction is internal force. You don't have any list because there is no such list. Internal forces are any forces which are in your system. It depends which system you are considering. In the questions, you will be given a particular system. A car is moving with a speed. There's a car, passenger, and whatever things are given in the question, that becomes your system. Anything else, that becomes your surrounding. All right. And when you have to find out the potential energy due to the internal forces, if your internal forces are acting, then this will be just negative of the work done by internal force. Just remember this. Gravitational potential energy, C class. This I'll tell you, this will take a little time. First, to note down that from here, make a heading, potential energy, start noting down.
Um, if a force is acted on a body outside a system, do we consider it?
If a force is acting outside the body, means outside the system,
Yes, ma'am.
then the potential energy is not possessed for that. Where the force is being acted, that becomes your system. They will be having their potential energy, but under the system which you are considering, no potential energy then produce.
Okay, ma'am.
Now can you go back up?
Ma'am, it is scroll up.
See, when we talk about gravitational potential energy, why are we doing this here? Because we are talking about potential energies, and this derivation comes from this lesson also. More than gravitation lesson, this is a part of this. So anyways, we have to cover in either of the lessons, we are doing it here. Just a very small derivation. Why or how are we getting the value which you people have studied earlier? See, what is the system here when we are talking about gravitational potential energy? It's Earth plus the mass of the object which we are considering. See, suppose this is Earth, this is a mass, this is an object of mass m. So this is our system right now. All the forces which will act will be the internal forces, and they are exerting potential energy on each other. Why? Because gravitation potential energy gets exerted when two objects are present. You have a Newton law for that, Newton's law, that we'll study later. But for just now, for this lesson, just remember the fact. You just have the next lesson as rotation and the next gravitation. So there you will study it in detail. Let's say the object was initially at point A. Now we have taken the object at this point P. So this separation is H. Now what all forces will be acted? This will be having gravitational force downwards. What is the angle? See, displacement. Displacement is occurring upwards. We are moving the object upwards. So displacement is occurring upwards. And where is the force acting? Force is acting downwards. Angle is 180 degrees. So what we'll do, we'll find work done's formula, that is Fs cos theta. What's the force acting? Force is mg. What is the displacement that occurred? H. And this is cos 180 degree. So work done by the internal force, because this is the system, this is minus mgh. So what will be the work done by external system or potential energy? What did we study? Potential energy is negative of work done by internal. So that will be minus of mgh. So finally you have potential energy as mgh. This is the formula. So what is this? This is a special case of all the potential energies. MGH is only this specific case, and that too when angle is 180 degree. That's why I am telling you, do not learn the formula of potential energy just as MGH. See how to use this formula. MGH is there. The formula MGH that we study, potential energy's formula is MGH, kinetic energy's formula is half mv square. So potential energy's formula is MGH, valid only for gravitational potential energy. It is valid for other objects also if their displacement that is occurring is h, mass is m, g is the acceleration due to gravity, force is mg, displacement is h. But do not remember it as a generalized formula. We have generalized formula. Do not remember it like this. In this question, we have to find out the potential energy, calculate potential energies in A point, B, and C. See, for A part, what is the potential energy? mgh, mass is 2, g is 10, I'm taking. Height, this is 0 of potential energy. 0 of potential energy means for potential energies, you'll always need a baseline. Then above the baseline, you take, it's like you are having the origin, x-axis is there, above it, below it. So any quantity above it will be positive, all the displacement values below it will be negative. So we take 0 of potential energy. 0 of potential energy means it's the origin. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this, you are having the values. So here displacement is 5, that becomes 100 joule. Because this is energy, so SI unit is joules. B part, formula will be mgh only. So mass is 2, G is 10. Now H, this is below the axis, 10 meters. So I'll not write it as 10. This becomes minus 10. So potential energy will be minus 100 joules. Lastly, C is here. See, what is the displacement? 0. Mass is there, force is acting. Displacement is 0. No potential energy is acted on the system. So delta G, because this is mg into 0. So that's why you have potential energy as delta U as 0. Now after this, okay, this spring mass system is very important. Note down this first, then we'll do spring mass system.
Ma'am, so potential energy is the external work done.
Potential energy is the external work done, but when we have our internal energy, potential energy is always external work done that acts. Work done is external, forces are internal, but work done is, that's why we put a negative sign, no? So that's why we are having, whenever you are having work done due to internal energy, you put it a negative sign. So external, if something is out of your system, that will also be, that will be the exact value that will be converted into your potential energy.
Ma'am, and the second one, it would be negative 200, right?
Oh, yes, sorry. I have written minus 100, minus 200. This is. Done, all of you?
Yes, ma'am.
Others also?
Yes, ma'am.
Fine, then let's study this spring mass system. This is very important. First, understand this, then again, you'll have plenty of time to write it down. Just understand this well. Spring mass system is a special case. Means there are so many systems that are possible, right? This system, that system, pendulum, length, so many systems are possible. But in your syllabus, there is special emphasis on this spring mass system. That's why we are studying it. Suppose this is a spring. And to the spring, I have attached a mass M. So what is this? This is the mean position, resting position. The spring is just kept. I have not elongated, I have not compressed it. It is just the spring is present as it is, the weight is present. So spring is present. I have attached a block of mass M. Now what I'll do, I'll apply a force. So now the system is just spring mass system. So the force that I'm applying, is it external force or internal force?
External.
External force. Very good, Harsha. The force that I'm applying, this will be external force. So suppose this is, I have elongated it. This was the mean position. No, now this has displaced X distance from the mean position, not from the origin, from the mean position. X displacement it has covered. And what is the force that has produced it to move? External force, which I have applied, any external force. Now the system has a tendency to apply the system. This will be applied by the system, which is the restoring force. Understand this well, because you have your last lesson as oscillations and waves. There also you study this concept, same thing, same concept. So understand here well, there it will be helpful for you. So force is a rotating force acts in the system automatically. This acts in a system. And what is the direction of this restoring force? It tries to bring the object back to its mean position. Or suppose, let's say, I have not elongated, I have compressed this. Then what would have been the case? If I have compressed this, this would have been the case. Again, the mean position is here. This is the mean position. This is the displacement that occurred from the mean position. Here, the restoring force will now act towards the right. Why? Direction of mean position, direction of restoring force was not towards the left earlier. It was towards the mean position. Since the mean position was towards the left, that's why restoring force acted towards the left. Now our mean position has shifted towards the right side. So restoring force has also shifted towards the right side. So restoring force will always act towards the mean position. You will be studying this same thing in rotation also. Rotating torque will also try to, restoring torque will also try to bring the object back to its mean position. So this concept remains the same. Restoring forces, whether is this system or the pendulum thread system. In that system, though that is a part of your last lesson, but let me tell you, suppose this is the pendulum. I have brought the pendulum over here. Fine. This was the mean position. I have brought it to its extreme position. Restoring torque will have the tendency to move it here only. The concept is same. See, if I bring it here, restoring torque will have the tendency to move it back here. That is the concept of the restoring force. Always remember this. Now, direction of restoring force is opposite to that of mean position. Fine. Direction of restoring force is opposite to that of mean position, not to the direction of, it is towards the direction of mean position, not. See, when this line is actually what it means, this can be confusing with this statement. Restoring force is acts always towards the mean position, and here it is saying direction of restoring force is opposite to that of mean position. This actually means your external force. This statement is not apt for this. This direction of restoring force is opposite to that of mean position means whatever is your mean position, displacement has occurred to the mean position. This means basically displacement over here. This means displacement. Direction of restoring force is opposite to that of mean position. This means. Now, regarding the magnitude, whatever is the force that has been applied, restoring force that has been applied, the magnitude of this is directly proportional to this displacement produced. You only think, if I apply a lot of force, a lot of elongation will be produced, a lot of displacement can be produced. If I just apply a small force, so small displacement will be produced. So force is directly proportional to displacement. Now, when you remove the proportionality sign, you get a constant. So this is written, restoring force is directly proportional to the displacement from the mean position. So F is equal to minus Kx. Now, what is this F? F is the restoring force. X is what? X is the displacement from the mean position. Now, what is this K? K is a constant which we call it as the spring constant. We call it as the spring constant. For different systems, you have different values of spring constant. This is actually a spring factor, you say. In general terms, we say it as a spring factor. But spring factor is a broad heading. Under spring factor, you have different system whose values are constant. So spring factor means the term constant. Just the term constant, that is spring factor. So if you have a pendulum thread system, that spring factor becomes 2 pi. If you have spring mass system, so that spring factor becomes spring constant like this. So for different systems, we have different values of the spring factor. Right now, we are not studying SHM. Right now, we are studying, actually, this is the condition of SHM, simple harmonic motion. So right now, what are we studying? We are studying the forces and their relation with displacement. We are just studying the spring mass system. So spring mass system, this is the spring constant, which we use. And why negative sign? Minus sign is telling you the direction. This direction, no, we say this, that it is opposite to that of displacement that occurred. This is what the negative sign is representing. This is telling you the opposite direction that has occurred. This is telling the opposite direction that has occurred. Now, what would be the formula for it? Why did we study this part? This part, no, this page, this is actually a part of your SHM. But since you have spring mass system, because under spring mass system, you have energy, potential energy. That's why you have to study. Now, when the derivation will come, start from here. Or you can start from there also. For derivation purpose, we have understood that part. Okay. This part is actually present in your SHM also. There also you can find, if you want to refer to the books in NCERT, oscillations. There you will find the same portion. In this lesson, why are we studying this? Because when I want to write the force, I will directly write, if I directly write it as Kx, then you'll not be able to understand what is this K, what is this X. That's why just a brief of it I have done. This is spring. This is mass M. Let's say this is the mean position. This has covered certain displacement X, and the restoring force is acting in opposite direction. Opposite direction to the displacement. When it was written, no, mean position, that's what I was trying to tell you. That mean position basically means the displacement that occurs. Yes. Now the work done in stretching spring from this X equal to 0 to X equal to X. work done in stretching the spring from x equal to 0 to x equal to x is what? How do we write the formula? Work done is equal to f dot dx from 0 to x. What is your f? You know, okay, let's substitute f later. First, let's write x dx cos theta. Do we know the value of theta? We know force and displacement are acting in opposite direction. That is the law only. That is the statement of SHM only. So theta, we know that it is acting. Theta is 180 degrees, right? Theta is 180 degree. So 180 degree, that makes it simply minus. So this becomes integral from 0 to x minus f dx. Now let's put the value of x. Now you know why are we putting the value of f as kx. Okay, so in your exam, you people can directly start from this part also. But when you are mentioning no, here, like work done is equal to integral from 0 to x minus kx dx. So mention in the bracket, since f is directly proportional to x, f is equal to minus kx, that's why this. You can put it in 1, 2 or 2 lines. Or the best way, if you people have sufficient time in the exam, just mention this part at least. This part. Or these two formulas initially. Because directly instead of using directly. If you do not have time, that's a different thing. But if you people have time, do it from there. Because this derivation is important. This derivation comes in your exam. This derivation is very important. This formula is very important. Everywhere you will find this formula usage. Attempt the question, attend the classes after class assessment. There also you will find this. Yes, minus k is common. Integration. So x to the power 1. What have we studied? X to the power n. This becomes x to the power n plus 1 divided by n plus 1. What is n? N is 1. So this becomes 1 plus 1 divided by 1 plus 1. And powers are from 0 to x. Minus k by 2. This becomes x square from 0 to x. Substitute the values. Work done becomes minus k by 2. X square minus 0 square. So this is equal to minus half kx square, right? And this is what, which type of work done? This is the work done due to internal force. Because this is the force that is acted is the restoring force, and restoring force is acting within the system. This is not the external force which I was pulling. We didn't consider it. We took the restoring force that was minus kx. So this work done is actually the internal force. So what would be the potential energy? Potential energy would be negative of work done due to internal. So change in potential energy is positive half kx squared. This formula is very important, class. Half kx squared. What is delta U? Delta U is the change in potential energy. Equal to half k is the spring constant. People who are preparing for entrances also, for you also, this is very important, this formula. X is displacement from mean position, not from the center, not from the origin, from the mean position. So this is displacement from the.
Ma'am, why are we integrating force?
We are integrating the force because we have dx with us, right? And we know very small portion. Dx is actually a very small part that has been displaced by the spring. A very, very small part. Suppose I have considered a very small part. This is dx. Now I am integrating it to expand it from the origin, that is my mean position, from 0. 0 is my mean position, to the end, towards the end of displacement. So that's why we are integrating it to find out. If we just know for the small part, we can find out for the bigger part, and that's the work of integration. Clear?
Ma'am, so the force is variable?
Force, which force? Force is variable over here. Yes, force is variable. See, force is depending upon x. This equation, no, F is directly proportional to x. F is equal to kx. If you put x as 1, force will be minus k. If you put x as 2, force will be minus 2k. Force is not constant. Force is completely depending upon the value of x as an equation, dependent variable and independent variable. So that's why we couldn't use simply Fs cos theta. We had to integrate it over here. Clear?
Yes, ma'am.
Okay, class. Note down this entire spring mass system and mark this as important.
Ma'am, can you explain this statement again?
This one, direction of restoring force is opposite to that of mean position.
Yes, ma'am.
This means no, from mean position, we are actually bringing the object. So this statement is actually meaning that mean position, instead of mean position, if you use the term displacement, it would be better. Because this was written in your NCRT, that's why I had written it exactly. This means from mean position, if you move, so direction of restoring force will be opposite. That is what is meant by. That's why I'm saying no. For this statement, do not remember the term mean position. Remember the term displacement. Then it would be easier. Restoring force is obviously opposite to displacement.
Okay, ma'am. Ma'am, in F proportional to X, is it F restoring or F external?
F restoring. Had it been F external, then in our final answer, our potential energy would have been minus only. Why are we getting plus? Because it was the first force internal. Restoring force is always produced by the system itself. External force you will apply. Through any other source, you will apply the external force. Restoring force will develop automatically. You never have to make restoring force develop. That will automatically be developed, which will be pointing towards the mean position. That's why we are saying this is a part of the system. And the external force which you will apply, that is nowhere mentioned because that is out of your system. Clear?
Yes, ma'am. Why did we get the cos theta?
Yes,
I'm like, how did we get the cos theta?
cos theta, see, it's the force, the angle between force and displacement. Restoring force is acting towards the mean position. Your displacement is always produced away from mean position. So both are anti-parallel to each other. That's why 180 degree.
Okay, ma'am.
Ma'am, could you call up?
Done.
Yes.
See class, the next topic, that is conservation of energy. So conservation of energy basically means entire energy in your system is constant. When we talk about conservation of energy of a system, we talk about all the forces that are acting in the system. There are so many forces that are acting in the system that generate energies. You have entropy, you have potential energy, kinetic energy, internal energy of the system. So many energies are present. There is one separate energy as internal energy also. These are part of chemistry. There you will study entropy and all you have here also in physics. So the thermodynamics is same, is common in chemistry and physics. So yes, so here, but in your syllabus, no, we'll be just talking about potential energy and kinetic energy. So it means sum of all the kinetic energy and potential energy present in your system is constant. Whatever energy is lost from one system, it is gained by that system. Now, two conditions which you should remember: non-conservative forces should not be present in your system, like frictional force. Viscous force is a force that will come. It's a type of friction force in fluids, you can say. And only conservative forces should be present. So kinetic energy initial plus whatever is the initial potential energy would be equal to final kinetic energy plus final potential energy. So this is what, this is the total initial energy of your system. This is the total final energy of your system. So change in kinetic energy plus change in potential energy is zero. Why change is zero? Because it is constant. It is conserved. So there is no change. This formula is very helpful for the questions, and this will be used a lot. All right, the proof part, we'll do it in the next class. Just write down these basic points. Rest of it I'll do in the next class. You have your after class assessment also today. Please appear for it. Text me done once you have written till here. Okay, Sarah, you can leave. After 5 minutes, you'll have your after class assessment.